So the square root of e to the x plus e to the negative x all over e to the x minus e to the negative x dx. So anytime you have something complicated, you want to pick the denominator to be your complicated part. So the only difference between these is that minus, but I'm going to make the denominator my u so that I can get 1 over u as part of my antiderivative. So my u is going to be e to the x minus e to the negative x. The derivative of that, well, the derivative of e to the x is e to the x minus derivative of e to the negative x is e to the negative x times negative 1. Negative times a negative gives a positive, and there's my dx. So du equals e to the x plus e to the negative x, which is my numerator. U is my denominator. So that means my integral becomes 1 over u du. Antiderivative of 1 over u du is the natural log of the absolute value of u plus c, which gives the natural log of e to the x minus e to the negative x plus c. Any other questions off that circuit training packet that you wanted to see worked out? Yeah. Is which one?
The one last page, top right one.
Yes. And I can send those again, but yeah. Anytime you have, which again, it shouldn't be on the AP exam, but if you see that u prime idea over a square root of 1 minus u squared, that's your arc sign. And you do need to know like the derivative of arc sign to get to that answer. So like if you had sine inverse u, its derivative is this. So, like, if you look at that one integral, it's like 3 over the square root of 9 minus 4x squared. Your u is going to be your u prime, which is 3. So your u squared is kind of your 4x squared, and then it, like, all manipulates down into it. So, just something to keep in mind. But from what I've read, this is removed from AP this year. But it could be on your mock exam because they're giving you the mock exam from 2018. I didn't honestly look at it. So it's not a bad thing to know, and if you're going to take Calc 2, it's something you'll learn in Calc 2. Yes, Caitlin. That's okay. So are you telling me like the x to the 1/3, 4x, or x to the 4/3 plus 9 to the 8? Okay. So your u is going to be what's inside that problem. Your derivative is 4/3 x, subtract 1 away. The 4/3 doesn't match, so we multiply both sides by its reciprocal. So you replace the x to the 1/3 dx. You replace the u. and you put your 3/4 du out in front. So you get 3/4 the integral from 0 to 8 du. And then that becomes 3/4. You add 1 to your u, so it's over 9 plus c. So you get 3 and 9, so that becomes 1/3. So you get x to the 4/3 plus 9 to the 9, all over 4 times 3, which is 12, plus c. And that should have given you 20, that should have been problem number 21. Any textbook questions you wanted to go over? Number 21. First page, middle right. Sure. So like square root sine x. Yeah. So I'm going to say 22. What? 21? I was like, we didn't do the evens. All right, so 21 is the square root of dx over x squared plus 9. I gave you another arctan. And if you'd have looked in the back of the book, you'd have saw. So again, there's your u squared plus a squared. Sorry, it's definitely an arctan. '21 was a bust. I thought I missed them all. All right, so in that first page, this problem here, remember the rule of thumb is whatever the exponent is for e is your u. So without even looking at this problem, my u value is automatically cosine x. The derivative of cosine is negative sine. The negative doesn't fit, so I divide both sides by -1. So the negative comes out in front. We get e to the u du. And then antiderivative of e to the u is e to the u plus c. So you get negative e to the cosine x plus c, which is actually the answer to the question, the other question you asked me about. So the good news is the couple that we did have a few questions on were pretty easily fixed. It's all pretty much involving our e's. Today's lesson you're going to like a lot. So we're actually jumping to chapter 8 because there is a rule It's called L'Hôpital's. And we're going to learn L'Hôpital's rule so that you know it for your mock exam. Because there's usually at least one, if not two,